Okay.
It's a hot plate.
So it's one of the words in your
The electric hot plate.
many of your procedures.
I think I'm gonna
The
have
same
to do
thing there
this.
too.
The
It is. Say
condense.
loud. Reflux. This is what a reflux looks like. Okay, so let's like really look at this carefully.
So how long is it
The
gonna
re-
hold here?
I'm not sure, it depends on the procedure. But first thing is this plate, which is called a hot plate. It's a stirrer. It has a magnet, so you turn this on to control the temperature. You turn this for the speed of the magnet. So for example, right now, there's the magnet down below, and if we were to see if I could see it here. Yeah, if you look closely, you will see.
Find out later.
I don't know, some of you might be able to see something spinning in there.
Oh yeah.
Yeah, so that's the magnet. So you don't have to stand for 4 hours or 3 hours and stir your stuff, okay? There's a magnet below there that spins, and you put a magnet in the flask, and so when the one below spins, it spins the one in the flask. So that's where you're gonna do your stirring. Some of you would do reactions without heat, and you might still need to use one of these plates just to get the stirring. If you're doing something without heat, you probably just want to use a magnetic stirrer. So you don't, you leave these free for persons who have to do stirring and heating. Okay? So this operates the same way. Got a magnet in here, and we'll be able to keep your reaction stirred. So that's the first thing. The magnetic stirrer or the hot plate stirrer, depending on its use. These are the control knobs here. This is for the heat. In most of them, it would have a dial that gives you this number. So one of the things that confuses people sometimes is that when we have this heat, right now it's on 325. That's the heat, the temperature of the hot plate. But that does not mean it has a temperature at which this thing here boils. If I were, this is dichloroethane, I think. The point is that a liquid, whatever solvent, some of you are using, let's say water and ethanol. What's the boiling point of water?
100.
100. Ethanol is less than that, it's about 78. When your mixture that's in the ethanol and water starts to reflux, it's going to reflux at the temperature of the solvent, which does not correspond to this number here. Okay? In other words, you do not turn this knob to 100 if you're trying to heat water, for example. That's probably not going to be high enough. In fact, what you want to do routinely, if you're doing a reflux, is to turn this knob to the highest possible, at least 400 or so, pretty high, so that the reflux could start fast. Okay, start fast instead of just slowly going up, you're wasting time. Let it start very fast, and then when it starts to reflux, what you guys should notice, both in this one and that one, is that there's a drip that's happening from this part. Anybody knows what this part is called?
Condenser.
The condenser. So what's happening is it's getting heated here, evaporating, it's boiling, it goes up into the condenser, which we'll talk about here soon, but the condenser is cold. You feel it, you'll feel it's cold because there's water constantly flowing through it. So it's evaporation, condensation, that cycle of condensation and evaporation, evaporation and condensation is happening, and there's a drip. That drip is pretty good here, reasonable rate. I don't know what it looks like there, but one of the things that you could use is the fact that it's not dripping or not flowing like, a tap. Okay, if it's flowing like a tap, basically the reflux is going too fast. So any sort of drip like this is good. I should put this back to 325 so I don't mess up the thing. It was at 325, correct?
I don't know.
Yeah.
Okay.
Yes, and then the spinning thing was at like 700.
Oh, okay. $330 is fine. All right, so
Project.
this is how you do a reflux. Some of you are going to be doing reactions with enzymes, and it says the heat. So there is a difference. What do you know about enzymes? If you were to heat them up, what would happen to the enzyme?
Denature.
It will denature. You do not want to reflux an enzyme, period. So what you're going to do, and I think we have worked out for some of these hot plates, is probably set the hot plate at 100, this number here, at 100, 125. The heat for, who here is working with enzymes? 1, 2. Enzyme?
Oh yeah, yeah.
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 Okay. So we are not going to try to do this where it's dripping back down, reflux. We're just going to heat it, and if you recall, we are heating between 50 and 55. So based on just doing this in the past, we have found that setting this to about 100 is what will give us that 50 to 55. But having said that, each hot plate is different. So for you guys who are doing the enzyme reactions, you have to pay very close attention, especially at the start, to make sure that you adjust the temperature dial here so that it's not going above the 55. If it gets to 60, we're still probably good. But yeah, definitely you have to pay more attention to the temperature. So you do not set this all the way to 400 like I told the guys who are doing reflux. Anybody doing reflux, it's okay to turn it up to like 400 to get it started fast. Once it starts to drip, you could turn it back down, but you do not want to turn it back down to like 100. Probably like 330 or something like that. Okay? Any questions on the temperature control? How many persons doing reflux? You guys have questions about what I just said about reflux? So nobody is going to start a reflux by turning it to 100, low here, and then slowly. You don't do that. You turn it up high, 400, 430. Once it starts dripping, it may drip pretty fast, and you then turn it back down, but you do not turn it down to 100. You turn it down to maybe like 300, 350, something like that. Any questions on that?
Isn't that kind of how making spaghetti works? Like you let the water boil and then you turn it down?
Good question. I don't know the answer. I don't know the answer. Anybody knows the answer to that?
Yes.
It's true.
There's an answer to that? Yes. Yes. So who's a spaghetti expert in here?
I mean,
I heard your voice.
connoisseur.
That's how you make more spaghetti, so.
Okay. There you go.
Spaghetti. Right there.
Okay.
Just don't have
All right. So
You make mac and cheese.
That's a very important thing that a lot of you are going to be doing day in and day out in your research, doing these refluxes, or in the case of the guys that are doing enzymes, are heating it, is the use of this. So, in terms of those who are doing reflux, and even with the enzymes, we still want to set up a condenser, even though we don't want it dripping, because the whole point of the condenser is once you start heating a solvent, whether it gets to the point of boiling or not, it's going to start to vaporize, and you can lose your solvent. That's why we put these condensers on, is to avoid the solvent just vaporizing, and basically over time drying up. You don't want that happening at all. In some cases, and this is kind of random, in some cases, if this is not like tightly secured between the condenser and the round bottom flask, you're gonna start to lose solvent there. And you might come back and find that your solvent is all gone and stuff is like burned. Yeah. Sometimes it's not, like I said, it's random and it's not your fault, okay? But try as much as possible. So one way to avoid this not fitting, the condenser not fitting directly onto the round bottom flask, is to make sure that when you clamp it, that you just clamp the top of the flask and don't mess with the condenser. So it just basically sits there, it's free, and you could put it in gently. Okay, so same thing here, you can see the clamp just clamps the top of the condenser. They don't try to clamp here or anything like that. They clamp just the top of the condenser there. So we have water to keep the condenser cold and to allow for evaporation and condensation. Notice that the water is coming from the tap and it's going to the bottom. So it's water in at the bottom and flowing out from the top. And this is a nice rate of flow here. You don't want it, especially if you're going to be running this reaction, reflux, for overnight or 6 hours or even 3 hours. You don't want water just gushing through there at a high rate, because it could bust out here and start leaking. So a nice flow, nice reasonable rate, water coming in from the bottom and going out from the top. So I'm going to encourage you guys after you do your first reflux, and we maybe are doing multiple reactions, you might change one aldehyde, but everything else is the same, one reagent. You can do refluxes in series. So imagine setting up another reaction here. All of this is set up. What you would do is take this water that's coming out and attach it to a condenser on the end. And so you could have like 3 or 4 reactions set up just from one tap. You guys get that? It's a series. It's like, yeah. Okay? So that's something that some of you will do. In the past, some people have set up 4 reactions at a time. Just pretty impressive for high school kids doing this for the first time. Okay? Any questions on reflux and heating?
How much money is expended in this process of running water for hours and using the power for the hot plates and the supplies?
I have no idea.